Okay, try to wrap your head around this. Your job is to track every single penny across billions of dollars in transactions every single day. That's the massive challenge Stripe faces. So in this explainer, we're going to pull back the curtain on their solution. It's a powerful internal system they call Ledger, and we're basing this whole breakdown on a fascinating engineering blog post they put out. Let's see how they pull it off.
So to really get why Stripe even needed to build something like Ledger, you first have to understand the mind-boggling scale they're working at. Just get a load of this. Over a single Black Friday to Cyber Monday weekend, they processed a staggering 300 million transactions. That's not over a year or a month. That's in just 4 days.
And what about the value of all those transactions? $18.6 billion. When you're dealing with that much money moving that fast, you have absolutely zero room for error. Every single cent has to be perfectly, and I mean perfectly, accounted for.
And that right there is the huge engineering challenge. How do you build a system that can track and validate this constant fire hose of financial data with, mathematical certainty? How can you actually prove that every penny is exactly where it's supposed to be all the time?
Well, Stripe's answer is a system they built from the ground up called the Ledger. Its entire purpose, its whole reason for existing, is to create one single, undeniable source of truth for every financial event that happens anywhere on their platform.
So what exactly is this ledger? Well, at its heart, it's an immutable and auditable log. Now that word immutable is the key here. It means once a financial event gets written down, it can never be changed or deleted. Think of it like carving it in stone. And that's exactly what you need for a system of record to be trustworthy, especially when the auditors come calling.
You might be wondering, though, why build a whole new system? Well, to get that, you need to know that Stripe, like a lot of big tech companies, uses a microservice architecture. So instead of one giant program, it's more like a whole universe of smaller independent services all talking to each other. You've got one for payments, another for payouts, and so on. The problem? They don't always speak the same language. Ledger's job is to be the universal translator, the single source of truth for all of them.
Okay, so how does Ledger actually pull this off? How does it take the complex, kind of messy reality of money movement and turn it into something simple and, most importantly, verifiably correct? The secret is all in how it models the data.
We mentioned immutability, and really, this is the foundational principle. The ledger is just a simple chronological list of events. This happened, then this happened, then this happened. That's it. Now, for the senior engineers watching, you'll immediately recognize this. It's a core idea in event sourcing. Because the log can't be changed, you can always rewind time and perfectly reconstruct the state of any account at any point in the past. It's basically a financial time machine.
The second big idea is the state machine. Now, that might sound complicated, but it's actually a really elegant and simple concept. Instead of thinking about a messy, multi-step process, Ledger just thinks about money being in different states, like pending, available, or in transit. And events are just the things that move money from one of those states to another.
Let's look at a super common example, a simple credit card charge. As you can see here, in the real world, it's a sequence of events, right? A charge gets created, it gets processed, and then, eventually, the money is available to the business. It's a process that happens over time.
Now look at how Ledger sees that exact same process. Instead of a bunch of actions, it just sees balances moving between states. A charge creation event moves money into a pending state. Then a charge release event moves that same amount from pending over to a completed state, which is the business's balance. By modeling it this way, the whole thing becomes incredibly clean, easy to observe, and mathematically verifiable. And this brings us to a really crucial concept called a fund flow. Because everything is just modeled as balances moving between accounts, Ledger can trace a single dollar through its entire journey. It can follow it as it moves from the payment system to the reconciliation system to the payout system. Teams that might not even talk to each other directly. And it can prove that the entire journey was completed correctly.
Okay, great. So we have this perfect immutable log of everything that should have happened. But how do we know it's actually correct? How do we catch bugs or errors in the real world? Well, that's where the second piece of this whole puzzle comes in, the Data Quality Platform, or DQ platform. You can think of it as the guardian of the ledger.
The DQ platform is relentless. It just asks 3 simple questions about every single fund flow, over and over again. Number 1, clearing. Did the process actually finish, and is all the money accounted for? Number 2, timeliness. Did the data get into the ledger when it was supposed to? And number 3, completeness.
Are we absolutely sure we aren't missing any data from the original systems?
Now, of those three, this idea of clearing is probably the most powerful, and Stripe's blog post uses this fantastic analogy for it. Think of money moving through their systems as water flowing through a network of pipes. The final balance sheets, those are the reservoirs at the end. When a process is done, all the temporary in-between pipes should be completely empty. If there's still water stuck in one of the pipes, you know you've got a problem.
This whole concept is built on a 500-year-old accounting principle, double-entry bookkeeping. The idea is simple. For every transaction, money moves out of one account, that's a debit, and into another account, that's a credit. The temporary in-between accounts are called clearing accounts. So, at the end of a successful process, these clearing accounts must balance out to zero. If they don't, it is a mathematical guarantee that something, somewhere, went wrong.
And this slide shows a perfect concrete example of how it works. On the left, you see a correct process. A charge is created for business A, and later it's released to business A. Perfect. Everything balances to zero. But on the right, look what happens. A simple bug causes the release event to be assigned to business B by mistake. The system catches this instantly because now 2 clearing accounts have balances that shouldn't be there. That's the water stuck in the pipes, and the DQ platform flags it immediately.
So this isn't just some theoretical system sitting on a shelf. It has a direct, practical use for the engineering teams at Stripe every single day. So let's take a look at how they use these metrics to find and fix real-world problems.
An engineering team at Stripe will look at a dashboard that's something like this. They can see right away that their scores for clearing and timeliness are great, almost perfect. But then their eyes are immediately drawn to this. Aging balances is down at 50%. This metric is tracking money that's been stuck in the pipes for a long time. It's a huge red flag that tells the team there's a persistent underlying bug they need to go hunt down and fix.
And this is probably the most important takeaway of the whole system. When the DQ platform flags an error, it's almost never a problem with the ledger itself. As Stripe's engineers say, these alerts reveal real problems. Problems with the underlying software, with how different systems are connected, or even with the actual physical movement of money between banks. So the ledger acts like this super sensitive diagnostic tool for the health of the entire company.
So what's the ultimate impact of building a system this sophisticated, this comprehensive? Let's talk about the results and where Stripe is taking this technology next.
The result is, well, it's nothing short of staggering. Stripe has achieved 99.99969%, that's 6 nines, of explainability for all money movement on its platform. To put that in perspective, for every $1 million that moves through their systems, they can account for everything down to a single penny. And they've kept that incredible standard even as their data volume grew by 10 times. It's a truly remarkable feat of engineering.
But of course, they're not stopping there. The next goal is to get even faster, to go from analyzing things daily to analyzing them at the minute level. This lower latency will open the door to things like even faster, more effective fraud detection. They're also building tools that let them create brand new kinds of financial reports, all built on top of Ledger, while mathematically guaranteeing that those new reports are also correct.
And this all leaves us with one final, pretty important question to think about. Systems like Stripe's Ledger give us a new level of trust, one that's based on mathematical proof. So as the world of finance becomes more instant and more real-time, how is our definition of trust in software going to have to evolve? What does it really mean to trust the code that's moving trillions of dollars around the globe? Thanks for joining us for this explainer.